Hello? Hello, hello? Anyways, my name is Seth. I'm going to be talking about what I do in my spare time. It involves propane and electrons. And not anymore, I don't. So I want to start off by just talking about things that are kind of awesome. And fire is definitely on the top of the list. Building things that shoot fire, also on the top of the list. Electronics, if you have a badge, and I certainly hope you have a badge if you're here, then you can tell that electronics are pretty awesome. Fire, it's not that dangerous, which is kind of a lie, but it's also kind of true. So I'm going to talk about doing custom electronics design for controlling fire art, which a lot of people see as really scary, but if you ever get in a car, then you're doing things that are just as dangerous as what I'm about to talk about. So a friend of mine, his name is Abe, he came up with a metric for how dangerous things are. And what he does is he looks up the statistic of how likely you are to be killed by this thing, and then he normalizes it against the chance of you getting killed by bees. This is, of course, a geographical thing, so it's normalized to the United States. So he has the KBB metric, which is killed by bees. And it actually puts a lot of things into perspective because, getting into a car, if you look at the KBB ratio for that, you might not want to get into cars ever again. So playing with fire is pretty fucking dangerous, but if you do it with a little bit of respect and knowing what you're doing, you might get killed by a bee instead. So other people think that playing with fire is pretty awesome too. I don't know if anybody has ever heard of hyperbole and a half, but apparently back in caveman days, fire was more popular than Justin Bieber. I don't know who that is, but I hear he's pretty popular. I'm not an extreme BMX biker. I don't have any drugs right now because I came from Canada and there's an international border crossing. And I certainly don't have a pet Pegasus. If anybody wants to help with this, that would be pretty cool. But I do make giant, crazy flame installations. Uh-oh. So what I'll be talking about, flame effects, and there's actually a flame effect back there in the back. That's a small tank one, but that gives you a good idea of what a flame effect looks like. And I'll be touching on subjects including plumbing and gas fitting, doing hardware and electronics design, as well as writing code to control the sketchy-looking box that's attached to the sketchy-looking device in the back there. And as an example, I'm not the first person to do this sort of thing. This is code from Interpretive Arson out of San Francisco, an effect called 2PyR. It's a Perl script that controls their fucking flamethrowers, but if you look at the function names in there, I was actually asked when doing a re-implementation of this to change the function name in case we got audited, and I didn't. So, fire the fucking flamethrowers, oh my god. Where are my slides? Okay. So on flamethrowers, I don't actually build flamethrowers. So any propaganda that I got you in here with about how I build giant flamethrowers for a living is a lie. Flamethrowers are bad. Flamethrowers are terrible. They're horrible. They're not something that you should fuck around with. I actually build flame effects. So what's the difference between a flamethrower and a flame effect? Flamethrowers are mobile installations, so you can carry them around with a portable fuel tank. So that thing over there is not exactly portable because there's no fuel attached to it. Trying to carry that around with you would not be realistic. Flamethrowers use liquid fuel. Flame effects, like the one back there, are vapor-based systems. So there's no liquid spray, so it doesn't qualify as a flamethrower. Flame effects use vapor. Also, flamethrowers are fucking illegal. So I don't do that. There's, in the United States, NFPA 160, code for flame effects before an audience, gives a good legal definition on the difference between flamethrowers and flame effects, and pretty much gives you 7 different classes on types of flame effects and what you need to do to get them certified and used before an audience. Flame effects can be anything from some crazy-ass propane rig like I have back there to using a candle on a stage in a play. Anytime you have fire before an audience, you're dealing with NFPA 160. They're pretty clear about what counts and what doesn't. So just for the record, I might use the word flamethrower, but I don't actually build flamethrowers because they're illegal. So I guess the question is, how does something like this begin? How does a person just get into the habit of building flamethrowers as a hobby? I did a lot of electronics work. I come from a background in programming and math, and hardware was always something that wasn't really accessible to me. So when Arduino came out, I started playing with LEDs and doing lighting, and I thought this is pretty cool. And it was a lot of fun starting to get into hardware stuff. And then in the city I live in, there was a Flame Effects for the Artist workshop where people who do this sort of thing, fire art installations, came by and showed us how to build propane-fired art installations. And we built this thing called the Valkyrie, which is there. It's just a very simple, hey, it shoots fire. There's a mask. If you blast it really hard, the mask flips open when the fire shoots out of the face. And this is what got me interested in this sort of thing. I don't know if anybody here has been to I3 Detroit, but I was just talking to somebody. They actually had this course there recently, so this is not exclusive to where I live. And from there, I decided I was going to start working on fire art projects of my own with some sort of custom electronics to control it. And the first project I decided to start working on was called PK4A, which stands for Pyrokinesis for Alex. And Alex is the one with the broken finger over there. It was called this because she's the last person in the world that you would ever want to be able to shoot fire with the power of her mind. So it started off with a very sketchy looking box. I decided to make it look as sketchy looking as possible, just for the hell of it. That box is now sitting behind you over there. It's the glowing thing sitting on top of the battery next to the fuel tank. All it is an Arduino with an LCD and a BlueSmurf module. So it reads data over Bluetooth, and if that data hits a certain threshold, it triggers the flame effect, which is just 12-volt power to the solenoid that lets vapor out of the tank. And this is what the rig looks like. It's now sitting directly behind you. This is a close-up of it. There's a screen that it tells you what the link status is from the headset and the mode, whether it's fired based on attention or meditation. And did I mention pyrokinesis, which means shooting fire with the power of your mind? This is the headset it's controlled by. It's on right now, so if people want to play with this, basically you put it on and then you focus. And what this is a wireless EEG unit that sends its data out over a serial Bluetooth connection to the box sitting back there. If you put it on, there are these reference sensors on the ear, and then this one that touches your forehead. So you just put it on, make sure that it's sitting well on your head so it can read your brain waves. And this thing is an actual EEG. It reads your brain waves, sends the signals over to that box over there, and if you're focusing well enough, it will make a clicking noise and not shoot any propane out because we're inside. But were we outside, like perhaps tomorrow night in a parking lot next door, but I'm not allowed to talk about that, it would shoot a 20 to 30 foot blast of fire up into the air. So if you want to try it, if people pay attention in the back, if you put it on and it's able to read your brainwaves, a blue light will come on over there. And then if it's firing, a red light will turn on and you'll hear a click. So if you want to just pass that around and let people play with it while I'm talking, that's the pyrokinesis box, and it does things like this. So this is the setup from Maker Faire Detroit. I was asked to tone it down for Maker Faire Detroit. Jeff, the fire marshal, took one look at it and looked really sad and said, "Is there any way you can turn this thing down?" And I said, "No, I really can't." And then he looked even more sad and asked me to extend the perimeter, and we did, and he looked even more sad and just decided not to come back. So this is the setup from Maker Faire Detroit. There's a fuel tank, and the tank that you see behind you is not actually a fuel tank. It's empty. And what happens is the fuel tank that connects to it lets propane vapor build up in that tank back there, and there's a solenoid valve on top with a pilot light. And when power is sent to the solenoid valve, it opens and lets the compressed propane shoot straight up. So you think with the headset, and it opens the valve, and it lets compressed propane shoot up, and it shoots a 20 to 30 foot jet of fire straight up into the air. This is the bigger setup that I had in the woods of Vermont. If you read crack.com, you might have seen it there under DIY supervillain devices. That was kind of awesome. But we used big tanks and in the woods, and this is what you do with it, and Alex isn't paying attention. But this is what happens when you're done with it. That's during the day. That's at night. All it takes is some focus and possibly meditation if that's your thing, and we switch it on to that mode. But it's just a brainwave reader that I built out of electronics that are available from like Arduino hardware and other stuff from SparkFun. Put it together, just a simple switch, and it shoots fire. There's another picture of somebody else blasting it off. So from there, I thought this was pretty cool, and I got involved in a project called the Heart Machine. This went out to Burning Man last year as an honorarium installation, so they covered a lot of our expenses and gave us a lot of support. But basically, we built a giant fiberglass and resin sculpture of a heart buried in the ground with 4 veins sticking up out of the ground with 2 flame effects in each of them, and these nerves sticking out of the ground as well. And the idea was that people would put their hands onto the nerves, which had LED lights on top of them. You didn't even need to touch it because it used capacitive touch sensors, much like the name pad on the badges here, same technology. And if you got 5 people touching them in a row, the flame effects out of the arteries would shoot off like a heartbeat. So if you got 20 people together all doing it at once, you would activate the heart and get it beating. So on this project, we had a lot of electronics work as well as the plumbing, and I actually designed the motherboards for each of the nodes as well as the LED lighting systems, because designing custom hardware to control flamethrowers is pretty fucking awesome. So this was the prototype of the motherboard. It doesn't look like much, but much like the prototype badge here, to make sure that it works properly, send it out for a test run and put all the parts in and see if it works. That's what it looked like with the parts. Basically, it's Arduino compatible system, optional Zigbee controller, 2 MOSFETs for switching out 12-volt power to the solenoids or to lighting, and it uses CAN bus for control. So they were plugged in a bus network topology using RJ45 cable, and we used that to burn about 500 pounds of propane in just under an hour every night for about 10 days. So it was one of those things where don't fuck it up, because if you fuck it up, people might die. Nobody died. So what technology is involved? The board's Arduino compatible, MOSFET switching for the power, capacitive touch sensors, LED controllers, CAN bus networking, all sorts of crazy stuff to make sure that we did it properly. And the boards that we used, I have some samples of the boards here if you want to pass it around, but that's the motherboard and the LED control board. So that's the electronics that we designed to control this sort of a system. And it ended up looking like this. Made it red because there was fire involved, and red and white. We're from Canada. We thought it was pretty nice. This was the prototype of the LED system. So this went under a plexiglass screen, and if you put your hand over it, there was an aluminum mesh, and that would register it as a touch and tell it to shoot off the flamethrowers. This is what the boards looked like before we put them into the system. they're not very complicated from a electrical engineering standpoint. So if you're a double E major, you've probably done many more complicated things like this. But I'm a hobbyist. I do this for fun. I have no background in electrical engineering. I got into it through Arduino, and it worked, and it didn't kill anybody. So I think that's pretty cool. And the end result was we put them in Tupperware containers to protect them from the alkali dust out in the desert. And that's what it looked like in each of the nodes. And here's a picture of me sitting on scaffolding, hooking up the power to the system. And the artery in the front, that hole is where the controllers went. And this is the end result, lots of fire. And this is what the entire installation looked like. The red LED lighting on the nerves was controlled by the same boards. Rather than sending 12 volts out to the flame effect controller, we just sent it out to 12 volts rope lighting. So all of the nerves would pulse and glow in the middle of the night when we weren't shooting off fire. This was the heart and more fire. That's another nice picture of one of the arteries lighting up. That's the team. This picture is actually a real picture. There was Photoshop involved, but not in the traditional sense. It's an HDR picture, but this is the team of people that it took to make something crazy like this happen. And this was the end result. So basically, designing circuit boards, building giant flamethrowers, pretty cool, and this is what you can do with it. I would highly recommend it to anybody else who's interested in doing this sort of thing. And that's the nice sunset picture, last one for this. From there, we decided to work on a project called Flux and Fire. There was a group out of San Francisco called Interpretive Arson. They made a project called 2PyR. We basically took their basic design and re-implemented it and tried to tweak it a little bit to adapt it to our colder environment. And what it is a platform that you stand on, and it has 16 infrared distance sensors in it with a ring of 16 flame effects in a bigger circle around it. And you move your hand or do whatever else around the ring, and the moment you trip a beam, it will shoot one of the flame effects off 25 feet out and make just a blast of fire up. So you could spin around and see the wave of fire. We had multiple kids on the platform doing it at once. We had people dancing or taking off their coat and spinning it around. And this is the sort of thing that you would get from it. Here's another example of a test run. So I have a note here for some video. Let me see if I can do this. So this is something that we did at the event installation that night. We decided to get some fire performers out and playing around on the installation. And it's a kind of a slow start to the video, but it will eventually get going. But we have two people who do fire sword fighting, and they were doing this on top of the installation. And eventually they get over to the platform where the sensors are. And there we go. So you might be wondering, how safe or unsafe is this? This is in Toronto, and Toronto has an organization called the TSSA. And TSSA stands for We're Assholes. And what that basically means is the organization, Technical Safety Standards Association, they're responsible for inspecting any installation like this before we're allowed to display it to the public. The thing I said about them being assholes comes from the fact that it's $190 an hour, a minimum 3 hours. They charge you for their hour drive to the city, even though their office is in the city. And then they look at it and go, well, we're going to need to see some more documentation on this before we approve it. Can you give us some more money at $190 an hour for a few more hours? This is very dangerous stuff here, but on the other hand, we actually have safety organizations that are the most strict in North America checking it out. So going back to the killed by bees metric, you're more likely to get killed by bees than get killed by participating in something like this. Here's another video of one of our team just testing it out, but this should give you a good idea. If anybody's seen a laser harp, works on the same principles and just is cooler because there's fire. So for this project, I developed a board I call the Wi-Fi 16. It is basically just an Arduino system. So the other side of this board has all of the same footprints, same components as the badges. It has a XB footprint, so it can be controlled wirelessly. And it's got 2 shift registers, so you send it 16 bits, and it shifts those bits out to 16 MOSFETs and then sends 12-volt power from a battery like the car battery in the back there out to the solenoid valves that control the flamethrowers. So after Flux and Fire, I did the board by hand, and there's just one very simple MOSFET circuit that I've done so many times to control these things that I got pissed off and I said, you know what, I'm never doing this again. I'm just going to make a PCB, and then fuck it, I'll always have the PCB around and never have to worry about this again. So that's the Wi-Fi board. I have some of these boards here with me. They might be getting passed around. Actually, I have a whole lot of boards in here that I was going to show off. So this is the prototype for the Wi-Fi. The prototype for the Heart Machine board is there too, and some other light boards that I've done. So making this board was the result of saying, you know what, I'm tired of soldering stuff into perf board and having to figure out which wire is broken, and we're getting inspected by a really nasty inspection agency that charges $190 an hour. So we're going to do this in a PCB, because if you have parts soldered into a green board, they look at it and nod and say okay. If you have a piece of perf board with wires everywhere, they look at it and go, that looks sketchy. So it's surprising how, you know, even just sending something out for a limited run costs like $5 a board to do, how much effort and money that can save you later on. So now, what am I doing today? Where has this all brought me? Well, Site 3, the art and technology space, hacker space, whatever you want to call it, that we have in Toronto. We're doing a lot more fire art projects to the point where we have a logo with a laser cut stencil that we now spray paint the logo on everything because it's pretty awesome. And we have a lot of propane tanks sitting in our space with a sign that I stole from Maker Faire when they were going to throw it out, because I brought this to Maker Faire and they thought fire was pretty cool. And I'm working on a project called Super Street Fire, which is kind of like Super Street Fighter, except rather than a video game, it's fire. So the idea is we're going to use the ring from Flux and Fire that I showed the videos of, and 2 people are going to stand on platforms in the middle of it, and they're going to have gloves with inertial measurement units that record the position and momentum of their hands, so we can do gesture recognition. So when somebody makes a punch move, it will send a wave of colored fire from behind them towards the other person. And then that person goes like this to block, and a wave of their own colored fire comes up to block it. From the PK4A project, we're also doing wireless EEGs for each person. So this is the really sketchy looking prototype unit for that here. So that if somebody is in a really zen state, they can block attacks without having to do the gestures, or if they're in a very focused state or enraged state, their attacks will do extra damage. So we're going to make these sensors for people, put them in the ring, have colored fire, and let them fight it out for a minute a round. We are doing all the flame effects ourselves. We are doing the hardware ourselves, or the software ourselves. We're hoping to demo this at Maker Faire Detroit. So if anybody is going there, you will probably, well, you will see this there one way or another, because this is why I don't have spare time these days. This is a picture of the test rig for the glove. We have somebody who does a lot of wearable electronics design making some pretty badass leather gloves for it, but we needed a unit to test with. So the thing up at the front is one of the SparkFun 9 degrees of freedom inertial measurement units. So it's got 3 accelerometers, 3 gyros, 3 magnetometers. It'll tell you the AHRS position, so roll, pitch, and yaw of the unit, as well as giving you the raw data for measurement of motion in each direction, as well as what direction it's pointing in. And we're doing everything over XB. So lithium polymer batteries, XBs to communicate back to the base station. And we're going to have 4 of the gloves, 2 of the headsets, as well as some other fire control stuff, all talking over Zigbee back to a computer. This is a picture of the hardware that we have developed so far. So there's the glove, there's the headset prototype, and there are 3 of the Wi-Fi units. One is for controlling the fire from the flame effect rig. The other 2 are for controlling spray units. We're going to have water or alcohol with metal salts dissolved in them and spray them into the fire to change the fire into different colors. So right now we're working with copper sulfate to turn it green, and some other chemical that we haven't decided on yet to turn it a second color, so that when you're fighting it out, you know which fire is yours. It's another picture of the Wi-Fi units. I don't know if one of those is going around, but if anybody is interested in seeing this board, I will definitely be in the breakout room afterwards. Here's the fire control unit that we have set up. It's just that piece of plywood with the cool logo spray painted onto it with the board screwed down to it. And the other thing is barbecues are not the same. Now that I'm working with propane, it's not nearly as scary. And again, killed by bees. Does propane kill you? Not really, unless you have a large tank of it and you light it on fire. Propane is non-toxic. This does not mean you should huff it. It is actually very common to get injured if you huff propane, because you will fall down and hit your head against whatever is on the ground next to you. But propane itself is actually non-toxic, and the flammability ratio of it is pretty limited, and the ignition temperature is pretty low compared to other flammable things. So it's a lot safer than playing with gasoline, as long as you're not a fuck up. So don't fuck it up. That's really it I have to show off. I guess we'll do more Q&A about building crazy-ass flamethrowers. If more people want to play with the unit in the back, that would be pretty cool. And some announcements while I have your attention. We're doing a mini maker fair in Toronto the weekend of the 7th and 8th. We're hoping to have a whole bunch of fire art up there, so if anybody wants to see it, or if anybody wants to come by and show off a project or participate in any way, I'd be happy to talk to you about that. After this, I'm also running the Charty Plus Information Security Certification, which tests you on the 2 critical skills of being a security professional, which are drinking and lying through your teeth. So if anybody is interested in participating in the Charty Plus certification, please come up to the breakout room upstairs after this talk. And I guess now it's all about questions. There will be a live demo tomorrow in the parking lot next door that looks pretty abandoned. I think a hastily made Cleveland tourism video used the phrase Scooby-Doo Ghost Town to refer to this place, which is actually pretty convenient. If there's any staff in the room, of course I'm not doing a live demo tomorrow, because that would be really bad. This is also a lie. So, yeah, I guess that's it. Well, let me go back to the questions slide. And okay. Anybody have any questions on this sort of stuff, what I'm doing? I was also going to talk some more about the LED stuff, but I didn't know how much time I would have with this one. So if anybody is interested in LED stuff, I also have LED controller boards here that handle RGB LEDs, individually sequenceable. If anybody does this sort of stuff, I have a ton of these that I'm trying to get rid of. So if you will actually use it, I would be happy to give you some of these. LEDs aren't nearly as exciting as fire, though. So I guess we will go to questions. Who wants to talk about flamethrowers? Nobody? All right. That's a question. I'm glad you asked. Actually, can I have some help moving this up to the front? Or can I just stand here even though it's not being recorded? Hello? All right. So this is a very basic flame effect. And I'm glad you asked because I wasn't going to go into this unless anybody asked. But this is really simple. The way propane works is when you get a tank for your barbecue, the tank is actually filled with liquid propane. So propane boils at about -40. So if you expose it to any reasonable temperature, it will immediately boil off, and that's kind of bad because vapor propane is about 27 times as much space as liquid propane. So if you try to contain it in an area, like a tank with a puncture in it, and it's exposed to higher temperatures, it will immediately expand and go everywhere. The going everywhere part is moderately dangerous because, yes, it is flammable. The problem is if you have a tank like this and there's a puncture in it and it's expanding, that means the tank goes that way really quickly. That's a problem. So if a tank gets punctured, don't light it on fire, but also don't get hit by it because they'll hurt. So the fuel tank sits somewhere over here connected by this hose. The way propane appliances generally work, of this sort work, is they let propane vapor boil off and then the propane vapor is ignited. In this case, this is called an accumulator tank. The accumulator tank fills with vapor. So this is not a liquid device, it's not a flamethrower. The tank fills with vapor and it comes up through this joint here and it goes this way. This is a regulator, what you'll find on a barbecue, so it drops the pressure very low. Comes out this copper tube, so you get a very low spray of propane coming out here. And then this little piece of steel wool here, if I can get it up there. Steel wool sits at the top and gets hot. And this means if there's any sort of wind, the pilot light won't get blown out. It will stay hot and reignite from the steel wool. So this is the pilot light, and this sprays towards the main opening. And this is the solenoid valve here. It's rated for 350 psi because the TSSA are assholes. This will never operate at anywhere near that, but that's what they require. These are really expensive for that reason. And when you send it 12 volts, in this case switched out through the crazy brainwave controller box, it will open. Who has the headset right now? Do you want to put it on? So make sure that the on the left ear, the metal pads are touching your ear and the one on your forehead is touching your forehead. And with any luck, the link number will drop. Is it off? It might have turned off on its own. Is there a blue light on the side? Okay, so put it back on. Make sure it's well seated. I might have to get the goo out. But the idea is when that triggers this valve opens and the pressurized propane in this tank goes up really fast. It hits the fire coming out from the pilot light and makes the fire. That's all there is to a flame effect. You can have all sorts of other crazy designs, but really all it is a vapor accumulator spraying out. It's also called a poofer because when it sprays, it goes poof. This is in contrast to a jet, which often don't use accumulator tanks. You're just spraying propane at high pressure to get the sort of cone of blue fire all at once. So this will give you a nice lazy depending on the pressure in the tank. And is the headset still not working? Where is it? Alcohol, it does totally work with alcohol. This has been tested along with a variety of other things for comparison. The problem with this is it uses dry sensors, which makes the brainwave readings sometimes hard to get. And the solution for this is medical grade goo. And by goo, I mean some sort of salt-based goo. Spectra 360 electrode gel. Can you hold this? So the idea is you take some goo, you put the goo on your finger. People really don't like this part. You put the goo from your finger onto the electrode and then onto the other electrodes. And all it's doing is allowing the conductivity, it raises the conductivity because what these electrodes are doing is actually reading the voltage from your brain through your skull. So you put it on and you hope it works because live demos never work. And the blue light is on and the red light means it's firing. And I kind of look like a jerk just standing here doing it. So does anybody else want to do it instead? Audience participation. Yeah, participation. The goo is safe to reuse, I promise. So that's how flame effect works, and that's how the pyrokinesis works. And I still have time, so are there any other questions? When the accumulator shoots its vapor up into the air, it creates a pressure vacuum, which then causes the liquid fuel in the fuel tank to boil and to fill the gap because temperature, pressure, all of that are related. I do not want to do a high school chemistry class here, but basically, if you drop the standard temperature and pressure, that's why you can have liquid propane in the tank at room temperature, even though it boils normally at minus 40, minus 44. Because you have contents under pressure, it raises the boiling point. So the problem is if you let the pressure drop, because you're shooting off the vapor propane in the accumulator, it will immediately rebalance by boiling off more propane until the pressure rises again and it reaches equilibrium. I know this is not nearly as awesome as actually seeing fire tomorrow night, I promise.
When you're doing the really large effects and you have a lot of accumulators, do you have a lot of small accumulators per effect, or are you using a lot of small? Are you using a lot of small accumulators, or are you using one big one?
It really doesn't matter. We generally use larger accumulator tanks, like 100-pounders, to have greater vapor to shoot off. So that tank over there, or that effect head over there, I usually use it with a 100-pound tank, which is about this tall. That just means the duration of the fire will last longer because there's more vapor in the tank. If you wanted to chain 5 20-pound tanks together, it would give you roughly the same effect. The problem with using a larger accumulator is when you're releasing vapor that quickly, it will cause the liquid propane in the fuel tank to boil off more quickly. And when that happens, the temperature will drop in the fuel tank. So you will actually see ice forming, even in the middle of summer, around the sides of your fuel tanks. And this is one of the big problems that we had with the larger installations, is when we were shooting off the propane effects very rapidly, it would cause the temperature drop in the fuel tanks. We'd ice them up, which would cause the pressure to be lower, and you wouldn't get as impressive blasts of fire. The solution to this is to put the fuel tanks into water and then use a propane fueled heater to keep the water hot, which will keep your pressure high and the fire going strong. No, really, you guys should all try this sometime. You all look kind of scared, or I will never do this, but it's not that hard. There's a book, Absinthe and Flamethrowers, about doing kind of dangerous things. The flamethrowers part is like, I was all excited about it. I'm like, yeah, this is great. And they're like, use a steam whistle and it'll be awesome. And that's all they said for propane-powered flamethrowers. So there's actually a lot of information about this stuff out there. You just have to know how to identify which is the stuff from people who've done this before and which is from clueless people who want you to die in a fire. If you look at places like the burner communities, if you look at people like Dave X and Eric Smith who do flame effects for the artist workshops, they're trying to teach people how to do it responsibly and safely and actually get more people doing this. It's not that dangerous. You might get killed by bees.
I came in late, so I don't know if I missed this, but do you do anything for colored flames?
Yes, on one of the projects I'm working on now, we're using, we're starting to test out pump systems with, usually you use methanol for something like that, but methanol is really dangerous because if something goes wrong and you happen to get sprayed by methanol, the only thing to do is chug a pint of whiskey and go to the hospital and hope you don't die. Putting a pint of whiskey in your first aid kit is actually entirely reasonable, but you can use propyl or we try to stay away from anything with any methanol in it, but even water with copper sulfate dissolved in it, if you use just a misting nozzle, like a spray bottle nozzle even, and spray it into the fire as it goes, it'll turn it a nice green. And there are chemical charts of which chemicals burn which colors, and you can pick them based on their cost and their toxicity and all of those parameters that are important to you. Are there any other questions?
When are you going to mount a flamethrower on top of your step fan?
Soon.
Do you do anything in regards to controlling the shape of the flame?
The question about controlling the shape of the flame, I have not yet started to do this stuff, but some friends of mine are working on it. If you control the pressure and control the nozzle shape, then yes, you can control the shape of the flame. How much you can control it is, we've done basic shape control stuff, but nothing really specific, nothing intricate. Other groups have had more success, but I have no idea what they're doing for nozzles. In theory, it's possible, but don't ask me. That's not an area I've touched.
What time is the demo that's not happening tomorrow?
The demo that's not happening tomorrow, I don't know, after dark, before Pixel Jam. I also, assuming I can find a place where the cops won't show up and I won't get arrested or make Notacon get shut down, the idea is there's a wild card entry, Pixel Jam. So the idea of showing up with a video saying I did this in the parking lot half an hour ago would be pretty cool. So just look for me, because I'm totally not going to do that. It would be wrong. Cleveland is actually very aware of NFPA 160 flame effect stuff, so it's actually not as wrong as you may think it is. Any other questions?
Do you get strange looks when you fill all your propane bottles?
I actually went to a industrial gas supply store earlier today to buy a hose. The reason I went to them as opposed to the other place is the other place asked me what I was doing and seemed kind of uncomfortable, whereas this place asked me and I said, I do fire art. They're like, oh, all right, cool. It really depends on who you're talking to. I have brought that rig across the border from Canada to Detroit. We had a non-North American in the car, so everybody had to get out and the vehicle had to be searched. And the trunk certainly didn't smell like propane. They didn't open it up and see that sketchy looking box on top of all that propane gear. And as we were going inside, I said, so about the trunk, there's some sketchy looking stuff inside. I assure you it's not sketchy. If you have any questions, please ask. And they said, thank you. They didn't ask. Don't bring fuel across the border, but that's, I called up U.S. Customs Department of Hazardous Materials Transportation, and they basically said, just purge a tank. It's not hazardous, not our problem. So, you might get some weird questions, but it's not illegal. Every question they ask, they have to write paperwork for. All right, well, thank you very much. If you have any questions, I'll be in the breakout room. If you want to participate in the Shardy Plus, which I certainly suggest, come up to the breakout room. Otherwise, have yourselves a great Friday night.